And today we're going to be talking about Unit 4, Notes 5, which is talking about trapezoids and kites. So we're going to continue learning more about different types of quadrilaterals. So let's go ahead and take a look at some properties of trapezoids and kites. So for starters, let's start by taking a look at trapezoids. So trapezoid is as a quadrilateral with exactly one pair of parallel sides. So exactly one pair of parallel sides. So like here, for example, this side is parallel to this side. This side is parallel to this side. This side is parallel to this side. Now notice that these guys aren't parallel. Eventually, if you would continue those lines going upward, they would cross each other. Now there's a specific type of trapezoid, that is an isosceles trapezoid. So the isosceles trapezoid has parallel bases. So the two lines that are parallel in an isosceles trapezoid are called the bases. And then the legs are going to be congruent. So the legs are the thing on either side that are congruent. So if we're taking a look at some of the shapes that we have, for example, this right here is an isosceles triangle. Our bases are parallel and then our legs are congruent. Same thing here, our bases are parallel and our legs are congruent. Additionally, in an isosceles trapezoid, the diagonals are also congruent. Remember, that's also a property of rectangles as well, that the diagonals are congruent. So this guy right here is congruent to that guy right there as well in a trapezoid. So again, these are just properties that you need to remember. Oops, I forgot this part. Both pair of base angles are congruent. So that means that this angle is congruent to this angle. This angle is congruent to this angle, and that's true for all isosceles triangles. Now let's take a look at some more properties of a trapezoid. The mid-segment of the trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So V is the midpoint of the line QU. S is the midpoint of the line RT. Okay, so that becomes important because of this trapezoid midpoint segment or mid-segment theorem. The mid-segment of a trapezoid is parallel to each base. So these lines are all parallel to each other. Likewise, this part has to be equal to that part because V is the midpoint. This part has to be equal to that part because S is the midpoint. So what does that mean? The segment of the trapezoid is parallel to its base, and each of its measure is 1/2 the sum of the length of the bases. So let's put that into terms I understand. So I want to figure out how long VS is. I want to figure out the length of VS. Well, the length of VS is going to be equal to the length of QR, whatever the number is they give us for QR, plus the length of UT. And then once we've added those together, we divide them by 2, and that will give us the length of our mid-segment VS. So that's something we're going to start applying as the unit goes on. So next, let's take a look at applying some of these. So we want to find the measure of angle D. Okay, so I see that my bases are parallel and my legs are congruent. So I know that this right here is an isosceles trapezoid. Okay, so because it's an isosceles trapezoid, I know a couple more things. I know that this angle is congruent to this angle, and this angle is congruent to this angle. So if this angle is 101, then this angle is 101. Now we don't know the measure, so the measure of angle D then is 101. Now we want to find the measure of angle B. Well, we know that B and A have to have the same measure, so let's just call it X. So then we have 101 plus 101 plus X plus X. Now recall that a quadrilateral has to add up to 360 degrees. So all of those angles in our trapezoid have to add up to 360 degrees. So 101 plus 101 is 202. This should be a plus. X plus X is 2X, and that's equal to 360. So now we need to solve this for X. So I'm going to subtract 202 from both sides. And then I get that 2x is equal to 360 minus 202, and that gives me 158. And then I'm going to divide both sides by 2 because that 2 is being multiplied by the x. 158 divided by 2 is 79. So the measure of angle B then, or each end measure of angle A for that matter, is 79 degrees. Now let's take a look at some more properties with the trapezoids. So it gives us that JKLM is an isosceles trapezoid. So if the measure of angle JML is 130, KN, I'm sorry, that should, KN, this guy right here is 6.7. And you know what? I am going to write this out here so that I can write in here. So the measure of this angle right here is going to be 130. Okay, and then it gives us that MN is 3.6. 3.6. Okay, so first it wants us to find the measure of MJK. Well, again, these two angles are going to be congruent. So I'm going to let those two be represented by the measure of angle X, because we actually don't know what their measure is. So this angle is congruent to angle M, so this guy right here is also 130. So I know that the sum of all of the angles in a quadrilateral needs to be 360 degrees. So I have 130 plus 130 plus X, and that needs to equal 360. So 130 plus 130 is going to give me 260 plus 2x is equal to 360. And now I need to solve this for x. Oh, that's just going to move the whole thing. Okay, so then I'm going to subtract 260 from both sides. And then just continuing over here, I get 2x is equal to 360 minus 260, which is going to be 100. Divide both sides by 2, and I end up with x is equal to 50. So each of those angle measures for our base on top is 50 degrees. Now remember, another property of a trapezoid is that the diagonals need to be congruent. So this line right here needs to be congruent to this line right here. Well, it's asking us the measure of JL, which is this entire diagonal. That has to be congruent to this diagonal. Well, KM, that entire diagonal, we know is congruent to JL. Well, we can figure out KM because KM is just going to be equal to 6.7 plus 3.6. So 6.7 plus 3.6, that's going to give you 10.3. So the measure of KM and likewise JL then is 10.3. Now let's take a look at number 4. Given DFGH is a trapezoid, so let's go ahead and draw a picture. With bases DF, so DF needs to be one of my straight lines, and then also GH. Okay, DF is going to be 5, GH is going to be 17. Find the midsegment. So the midsegment is going to be a line going through here where those points on either side are the midpoints. So to find that, all I'm going to do is I'm going to add my two bases and divide them by 2. Well, 5 plus 17 is 22, and I'm going to divide that by 2, which is going to give me 11. So the midsegment of that trapezoid then is 11. Now let's take a look at number 5. So for number 5, in the figure, MN is the midsegment of the trapezoid JFGJK. Find the value of x. So I know to get the midsegment that I have to take the sum of my two bases, which are 20 and x, because remember your bases are these lines on the trapezoid. And that's going to be equal to the midsegment. So now I have to solve this for x. So the first thing I want to do is get rid of that divided by 2. Since this entire top is being divided by 2, what I'm going to do is I'm going to multiply both sides by 2. Well, that's going to cancel that out. So then I get 20 plus x is equal to 30 times 2, which is 60. So now I want to solve for x. So since that's a positive 20, I'm going to subtract 20 from both sides. And then I get that x is equal to 60 minus 20, which is 40. So x is equal to 40. So that's the length of that base. Last but not least, let's just go over some properties of a kite, and you'll practice some of these properties on your practice worksheet. A kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So the congruent sides actually have to be in order. So this is congruent to this. They're consecutive. This is congruent to this. Again, they're consecutive. In a kite, only one pair of opposite angles are congruent. Okay, so this pair is congruent to this pair. They have to be opposite, but this and this are not parallel. So they have to be opposite each other. And notice that they're between, the opposite angles that are congruent are between two non-congruent sides. The opposite angles that are congruent are between two non-congruent sides. So we can say that angle J is congruent to angle L. Well, what else do we know about kites? In a kite, the diagonals are perpendicular. So we don't know that they are equal to each other, but we do know that they are going to form a right angle. Okay, so the diagonal between the non-congruent sides bisects the pair of angles. So here, we're going to have, so angle AC. So notice it's between the pair of non-congruent angles. So A is not congruent to C. So they're not congruent, but the line AC is going to bisect angle A and angle C. So it's going to bisect the angle. Okay, that means it cuts it in half. So angle HAC, or BAC, sorry, is congruent to CAD, and so forth. The one thing I want to point out to you before we finish up this video that's going to help you on your homework is that kites form 4 right angles. So if it's asking you for a distance and you don't know how to find it, check to make sure that you aren't trying to build a right triangle. Okay? So that concludes your note video today. Thanks for listening, and show me your note sheet when you're done.